everybody, welcome back to Space Explorers with me, Cam, and we have Professor Lewis Dartnell from the University of Westminster,
This guy.
and Seb from
This guy.
where are you from, Seb?
From Staffordshire
From the
University.
School of Hard Knocks.
For the old 2-1 in film production
Nice.
technology.
Well done.
So welcome back to another episode of Space Explorers, the last episode of Space Explorers.
It's
Last
true.
of 6.
Lewis, you've been in all 6.
I have.
And so we thought we'd finish by just having you all on your own.
Not that someone cancelled last minute and had to try and squeeze me in. But this was planned from the beginning.
Maybe I'm the guest. Did you think about that?
Well, I hope you've got all of the answers.
I see. I have no answers.
Seb's been studying astrobiology for the last week, and he's
Yes,
here to
and
answer
all
all of
the
your
magazines.
questions.
Hella scratched up on this. But Lewis, we are talking about life beyond Earth today because that is your field.
That's what
of
I do.
expertise.
That's my astrobiology research.
Yes.
Funded with the UK Space Agency on
Yes.
the fellowship I've just been finishing.
Yeah.
And the ExoMars rover, which we've heard from a couple of our interviewees, our guests so far.
Yes. So we are going to be playing a game called Waking Mars, which is, as you can probably guess, set on Mars, and there is life in this game. So we're gonna play through it together, guys. It's quite story driven, so we're
Okay.
gonna and there's maybe a bit of problem solving as well.
Oh,
but I
sounds
reckon
good.
our three
Perfect.
mighty brains can handle it.
So here we are landing. I see
no,
we're
no,
landing.
we've- so we've already-
we've already landed.
We've already landed.
Here's our biome that we're in.
This is our biome, and
Looks
guys,
just like you, Lewis.
meet Lang.
Yeah.
And this is Amani. Amani and Lang. Aha. So the descent.
The
Now,
descent.
Lewis, my first question for you.
Yes.
Are there caves? You're not Lewis. Are there caves on Mars?
Remember, I was scratching up on this, Lewis.
Yes.
But are there caves?
But you're going to let me take. You're going to let me take it this time.
But why don't you fire
But you
this?
know what the answer would be.
Yeah.
There are. We've seen them. We've seen them from orbit. We can see
Okay.
where there's lava tubes where volcanoes erupted and the magma's kind of flown and solidified and cooled on the outside and left these hollow tubes. Like we see in places on Earth as well. And in some places the roof of that tunnel has collapsed down to leave a kind of skylight. We can look down through into these caves on Mars.
We seem to be having
So far,
here.
this is pretty realistic.
I guess jetpacks would be more efficient on Mars. due to
Well, the
less
gravity's
gravity.
weaker, exactly, yeah.
So,
you might
yeah.
have problems with trying to control it, not just flinging yourself sideways into the wall of the cave.
Lewis,
So we got our first
It's life.
alien life form down. These, I mean, they look kind of Triffid-like, don't they? These plants here.
Now, apparently they're called the Zoa
Zoa.
in this
Zoa,
game.
of course, yes.
You're the first person to make contact with extraterrestrial life.
High five, Liang. Well done.
He beat you to it, Lewis.
Yeah. Also, how much light? Because we're talking
so-
about like at least 2 different forms of life here,
Oh, really?
right?
Oh,
Well,
yeah.
There's the little bug things.
Are they little bug things?
So
or are
I
they
assume there were
pollen?
moats of dust floating around, but yeah, they seem to be
They
little
might be
midges or
little
something,
bugs.
don't
I
they?
don't
Yeah.
know.
Well,
So I'm on
something's
board.
gotta
I'm on
pollinate
board with the prospect of life underground on Mars. That makes quite a lot of sense.
Yeah.
Not so much plants. I
Not
suspect there's not
photosynthetic
much light underground.
Well, we don't know that these are photosynthetic.
Well, true. I mean, they look green. They've got
They could be
leaf-like
green for
things.
some other
Maybe
reason,
they're
Lewis.
close to fungus to mushrooms.
Don't bring
that
your
don't need
Earth
to grow by
logic up
sunlight.
in here. They could
This
be
is
green for
Mars.
another reason.
I
yeah.
heard that they actually eat meat, and that many
Don't
people
go
have stumbled on
too
them for the
close.
first time.
Here we go. Now, immediately, I don't know what you think about the ethics of this, Lewis, but as soon as Lang here, astronaut Lang, picks up a seed, his initial reaction is, I'm going to plant this and mess with the local ecosystem.
With the system, yeah.
Messing with-
What do you think about that?
I don't know. I guess it's not all that bad, and that the seed's already there and the plant's already there.
Oh.
What would be worse? We'd be bringing seeds from
Wow.
Earth and then trying to plant them.
Okay. So, are there any plans when we get ExoMars on Mars? Are we going to send the rover down into any caves, or is that just way too dangerous?
Yeah, so not with the ExoMars rover. That will be just trundling across the surface, trying to find places where there might be signs of life being preserved. ExoMars will be drilling underground, though. We'll have a 2-meter long drill bit, so kind of for the first time ever, we're going to be able to get a good arm's length underground on Mars. And
That's a very
grab,
good arm.
Grab,
I mean,
it's a long 2-meter arm,
yeah.
a giant arm, and grab handfuls of Martian dirt to bring back up to the surface to analyse. But the idea is for future missions, we'd want to get underground further. We want to try and find these caves where stuff might have been protected from the Martian environment for longer.
So, is there a reason why you settled on 2 meters? Was it like a technical restriction?
More of an engineering restriction, I think, yeah.
I see.
So the radiation on Mars is a very big concern with the cosmic rays and essentially nuking anything in the surface and killing the cells and breaking down their molecules. But after about 2 meters, that's been substantially reduced just by the solid mass of the rock absorbing it.
So, if you had an ideal drilling depth to go to find the soil that you want, how far are you talking?
So 2 meters is pretty good.
Yeah.
If we could go 3-4, that'd be better, I guess. It would be slightly better. But a 2-meter long drill bit is itself far longer than anything we've tried before.
Yeah.
So with each new space mission, you try something new, something a little bit better than what you've done before, and then and learn from the process through. But when we start sending humans to Mars, we're absolutely going to be wanting to put them inside caves and maybe inside these lava tubes, because then you've already naturally got that massive rock above your head.
Reckon this could be a lava?
Shielding.
Could this be a lava tube?
One we're in at the moment.
Yeah.
Yeah, it could well be.
Here we are. We're doing pretty well, guys. Now,
Also a
we're
new
about
kind of
to
plant now.
Encounter a new kind of plant.
Tentacle plant.
That one hurt. You just hurt
Did it?
yourself
Did I
a
hurt
little.
myself?
You did.
We've discovered a new life form.
He's spitting at you. He's not so keen.
No. Okay, so it's just spitting water at you.
Yeah.
So what it wants me to
That's
do
quite nice,
is
actually.
chuck these globules of water at these ones.
Okay.
Which makes
Hey.
sense. All life on Earth is based on water, as it's
Now,
liquid stuff.
this is going to start producing the green seeds. So what they've basically given us, when you have both
So
of
we now
these,
learn that green seeds, you have to get through the gates.
they need
We now
wa-
know how to make them.
Yes, they need. Yeah, exactly. So these plants need water to produce seeds. Another one. Hey,
Man, so much life on this planet.
just because
Yeah.
I know there's too much life. Let's kill it.
Yeah, so there'll be different kinds of biosignatures, different signs of life we'll be looking for with XMars. And that could be simple organic compounds, maybe things like amino acids that make up the proteins in our bodies.
Oh God, too many
Maybe
seeds.
more complex organics. And we have different bits of equipment and instruments, different science experiments on board XMars to try to make those measurements for us. And hopefully, this is what everyone's gunning up towards. Hopefully XMars will make some very exciting discoveries of organic molecules and potential signs of life on Mars. But the frustrating thing, I guess, is we won't be able to bring those samples back to the Earth to study more closely. XMars is a rover we're going to send there and it'll drive around for a bit, but it's never coming back to Earth
No.
afterwards. So the next step after that would be what's known as a Mars sample return, where we do send a rover or a mission to Mars with its own rocket that can launch back off the surface of Mars, travel back through space, come back to Earth, and bring those samples of Mars rock and maybe soil from under the ground back to Earth, where we can study them with all of the laboratories around the whole world and get to really know that sample and use more sensitive equipment to try and find those signs of life and characterize what it might be like. Yeah, so XMars launching in the year 2020. And then, I don't know, maybe a decade, maybe a little bit longer after that, we'll be really pushing for a Mars sample return mission.
Oh God,
Get
God,
out
don't
of the
go in the
acid.
acid.
Okay, you've got one health bar left.
Okay, so
So go get some delicious
Get some
delicious
water or
acids.
something.
Some water.
So the acid's really interesting, actually, because a lot of the signs we see of what we think are ancient lakes and seas on Mars do appear to have been very acidic. And this is what the Opportunity rover, which is a NASA rover, found. The minerals that have been left behind by that water are very sulfur-rich. We think there's sulfuric acid was quite acidic in that lake water. So the big question, of course, is whether it's too acidic for life to have got started or survived in there.
would you expect to find like pools of acid? Is that a thing you could find on Mars?
But perhaps not bubbling pools of acid like in this game, but the
Oh,
maybe we just got
I
stabbed in
died.
the head by a stalactite.
oh, I
yeah.
died. I'm so sorry.
You're not an extremophile,
So
Cam.
this is why I'm not an astronaut, because I jump in pools of acid.
But but Lewis, you have studied how the kind of hardy conditions, or the hardy life forms that can survive in really extreme conditions.
Yeah, so not bubbling pools of acidic water like we got in the game here, but the seawater or the lakes that we found in some of these landing sites where rovers have seemed to have been quite acidic. And maybe that's not a problem. As we say, the extremophiles we find on Earth can survive in very hostile, nasty conditions of very high acidity, very high alkalinity, very low temperatures, very high temperatures. These are the extremophiles, these are the extreme lovers that tell us about the kind of survival extent of life on Earth. And for what we know of these extremophiles on our own planet, then yeah, Mars does seem to have been habitable, to seem to have the right environment for life to got started. Although I should point out we're talking about very simple, single-celled, bacterial-like life and not trifid-like plants like we've got on the game here.
No.
We're finding more life forms, guys. This seems to be an
So these
acid
look a lot
plant.
like snotites, which you do get in caves on Earth.
What's
so
a
it's
snotite?
So snotite is kind of like a living stalactite. It's a structure made up of bacteria which are kind of excreting particular minerals to build up the stalactite, but they grow in exceedingly acidic conditions, and they kind of ooze this acidic water, which is a byproduct of
exactly
their
what this is
metabolism, and
doing.
that's what we can see.
All right.
There you go.
And then they're called snotites,
So
which
this
I
is
think
a-
is a great scientific name.
That it is a perfect name, and it's the first thing that we've seen so far in this game that you legitimately
Yeah,
has a bit
I
of...
give this a science tick.
Oh, yeah.
So I think that the trifid-like plants growing in the darkness of a cave. But I'm liking those snotites there.
So basically, but I should have said we're on the trail of a robot they sent down here initially, and that seems to be its camera module. We kind of lost contact with it.
Oh, I see, yeah.
So we're gonna go and collect that.
Okay, find a bit. We can fix it on the fly.
So the robot got all the way down here and didn't send us any pictures of all that life that it passed. It didn't think it was relevant to let us know.
Nope.
Apparently.
He's only interested
Robots,
in other
eh?
robots.
Oh, yeah.
I use the subsurface shallow radar, and I'm pretty sure this is a body of liquid water.
Wow.
There it is.
Interesting. So this is really interesting as well with the ground penetrating radar, which is exactly what ExoMars will also have on its other instruments.
Oh,
It's
yeah.
going to be a radar that will ping underground, try to work out what the structure is, where's the best place to drill, so we don't, just hit hard rock and break the drill.
Break the drill straight away.
And we've got other systems in orbit which are much more powerful radars, trying to look for subsurface water or at least subsurface ice, the cryosphere beneath the surface of Mars.
Oh dear.
It's all going horribly wrong. Lying, no. Uh-oh.
Oh dear.
Oh,
Look what we've
they
done.
should have used that radar to find some nice rocky stuff.
Should have seen the snotites were right beneath us.
Yeah. Whoops.
I assume we're going to use our newfound knowledge of the life forms to escape.
To escape and get back to the surface,
Ah,
yeah.
a light in
yeah.
the dark. Here we go, guys.
These plants grow really quite quickly. Is there any life on Earth at all that has the ability to grow? I mean, maybe not within a few seconds as this
Ooh,
does, but like
look at
maybe
this.
within a day or a week or something.
Yeah, so a lot of bacteria can divide very, very quickly. The kind of E. coli and stuff in your gut can divide every 20 minutes. It's
Wow.
incredibly rapidly reproducing.
Yeah.
But the sort of life we find deep underground on Earth, so the life that's living in kind of cracks in the crust of the planet itself, like kilometers and kilometers underground, these things will divide incredibly slowly because there's very little nutrient underground for them to grow on, and we think these things might divide on the timescale of like months, if not even years. So compare
Wow.
like 20 minutes for something in
Okay.
ideal nutrient-rich conditions in your gut to life deep underground, like in this game, dividing every few years or so. That's life in the slow lane. That's taking things chilled out. And trying to eke out the nutrients you've got available to you.
We saw that there's going to be a body of water somewhere in this game, and it looked like it was in liquid form. But you think most of the water that we could possibly find on Mars might be ice, or is there any that's still liquid?
Yeah, so we know there's lots of water on Mars. We can see great big polar ice caps of solid water, of water ice on the North and South Pole, as well as carbon dioxide ice, kind of dry ice. And with various of our instruments that we've got orbiting Mars, we think that there's kind of permafrost, a cryosphere of ice just beneath the surface, and particularly in the northern hemisphere. There's good reason to think that once, a long, long time ago, on primordial Mars, that the entire northern hemisphere was this great ocean.
Oh, cool.
And all that water was seeped underground and frozen as Mars has kind of cooled down and lost its atmosphere to outer space. But you're right, the more interesting question is not just is the substance of water on Mars, but how much of that is in its liquid state, how much of that water is wet and fluid and runny, and the kind of water you would need to use for life and cells. And so maybe at the base of this cryosphere, this shell of ice underground on Mars, maybe the geothermal heat, just the kind of warmth of the planet and its interior, would be enough to melt that ice into aquifers, into liquid water. And that's what we've been trying to look for with our ground-penetrating radars. Orbiting Mars, as we've seen in this game as well.
And no success yet?
No clear signs of liquid water. And again, we're limited to the depth that we can penetrate underground with our radars, and all these sort of limitations. But even if there's no aquifers of liquid water under Mars now, maybe we'd still find signs of ancient life, of extinct life that was once blossoming and thriving on Mars, but is now dead, and we can still find its biosignatures, the signs that it was once there.
Hey, 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 hey.
Look at him.
What happens if I hit them with water?
That works.
You got him. He's doing his thing.
Oh,
There you go.
I know.
whoa.
He's dropped a hand grenade for you.
He's kindly wrapped it in rope.
Mind you,
Oh,
he
he
reproduced.
gave birth. In fact, it seems to be interspecies reproduction.
It
What, in
is
what
a
way?
little bit.
Well, this seed came from a different species.
Oh, but it's eating the seed though, right? That's in the same way that you can eat an apple and then make babies from the energy from the apple.
Oh my god!
It's not.
I'm never eating apples again.
It's normally that you eat the apple and it just totally puts you in the mood.
I love apple.
So maybe they're dividing asexually. Then, what do you think?
I think they are. Yeah, I think they're spawning. They're reproducing asexually, like aphids and things. They're like little gold nuggets.
So
Shut
it
up.
can only be planted in particular places.
I already know exactly where it'd be.
Of course you do.
Because it's color. Did science always like this, Lewis? Did colors just match up? Oh, we put the yellow thing in the yellow thing.
They're giving you a
course.
big clue.
There you go.
Are you friendly?
It's going to make a new spiky thing.
Ah!
He's not friendly.
Not entirely
He's
friendly.
not friendly,
as it turns
but he
out.
loves acid.
Now I just need to find a plant that turns into a gun so I can shoot them.
So we've mentioned, even on other episodes of Space Explorers, that Mars itself, on the surface, is subject to some quite severe radiation.
Yeah.
But where's it coming from in space?
Yeah, so this isn't like radioactivity in the way that you don't want to get too close to a lump of plutonium kind of radiation. These are the cosmic rays on Mars, and that you expose yourself to as soon as you go beyond the Earth and its magnetic field and its atmosphere, are particles that have been spat out by things like solar flares on the sun, or accelerated by supernova, by stars exploding throughout the galaxy. So these are kind of atoms of hydrogen all the way up to the nucleus of kind of iron. So really chunky particles traveling very close to the speed of light, which are incredibly dangerous.
Okay.
If it starts hitting your cells and kind of damaging your DNA and giving you cancer. And the case of the simple microbial life we might hope to find on Mars, killing those cells off, killing those bacteria, and then once they're dead, kind of trampling on its ashes and breaking down the molecules it's made up of.
So
that's why we want to go underground.
It really wants no evidence.
Yeah, it's
that
having
life
none
ever
of this
existed.
life.
Oh, okay.
It's kind of the idea that I kind of talk about is it's almost like it's kind of erasing the signs of life that have been there.
Wow,
and-
you really
and
are
degrading them.
battling against it in this.
So this is why we want to go underground with our ExoMars drill to 2 meters to get beneath that cosmic radiation penetration depth.
So once you've actually pulled that sample up, and you feel like this is going to be the sample that's got
Feeling
life.
lucky about this one.
Yeah, I mean, how do you even go about finding the life? Like, what kind of instrument finds life?
Yes, there's
soil?
different bits of kit that we've designed ExoMars to have. One of them is the GCMS, or Gas Chromatography Mass Spectrometer, which is a fancy science term for essentially kind of an electronic nose. It's a way of detecting particular molecules and kind of sorting between them so you can kind of smell or taste what's in there. And it gives you a spectrum at the end. It gives you a graph of lots of spiky lines. And if you know how to interpret that, you know what compounds and molecules you're looking at.
Right.
So we'll be looking for particular kinds of organic molecules, kind of carbon-based molecules, the kind of Lego bricks that make up all life on Earth. So kind of amino acids and sugars and all this kind of stuff. And ExoMars has one of these on board. And it's got other bits of kit that we'll be using to look for biosignatures as well. And the one that I'm working on, you've just jumped off a huge cliff there.
Oh dear.
They won't let me do anything.
Off to your doom, I guess.
The particular instrument that I'm working on, the Raman spectrometer, is a laser-based instrument.
Delicious.
And essentially what you do is zap your laser at the sample, the Martian soil you've dug up from underground, and then you look at the light that comes back off from that sample, and most of it will be the same color of laser light you sent. So we're using a green laser, like a laser pointer.
Yeah.
But some of that light will have bounced around inside the sample and interacted with the minerals and any organics that might be in there, and so it gets shifted to different wavelengths, different colors. And so you get a spectrum out with some spiky lines on it, and you interpret those to work out what different minerals and rocks are in there, and what different organic molecules might have been in there. So Raman's a really nice kind of 2-for-1 instrument, I guess. You can do two things at the same time with it, and it'll tell you not just about organic carbon rather than that kind of carbon dioxide. It'll tell you about the kind of carbon that life is made out of. And hopefully particular compounds. So the kind of samples I work with from these very extreme environments on Earth, like the Antarctic dry valleys right in the South Pole, or the Atacama Desert in Chile in South America, which is pretty much the driest spot anywhere on planet Earth, one of the most Mars-like places on planet Earth. And I've been working with a lot of samples from places like that. And when you do Raman spectroscopy on these kind of samples of bacteria that have colonized inside the rock itself, you get particular fingerprints of things like carotenoids and scytonemon, so the compounds that these bacteria have used to protect themselves. We're kind of seeing like the ultraviolet shields that these bacteria are using to survive in these really harsh environments.
I'm sure those are two words that you throw around
all
on a
the time.
daily basis.
They just trip off my tongue, can't you tell?
That's definitely not one I've heard before in the old GCSE science.
So like carotenoids are common things on Earth. It's what gives a carrot its orange colour and aubergine its purple. It's what turns autumnal leaves the kind of the glorious colours that they are. But carotenoids are used more generally by life, and particularly by bacteria, to kind of help shield and protect them. And so there's a reasonable chance that life on Mars, Martian life, might use similar compounds that we could pick up using these techniques. So that's what we're hoping to do with ExoMars.
Well, the good thing is, I think we're now at that point where everything's having knock-on effects. Like, if I keep feeding these guys and then herd them like some sort of horrible farmer towards the death
the
plants.
carnivorous plants.
Come and see the death plants. Okay, you can give birth first. No, you can't. I scared you. Come and don't hide down here. Go see the death. Oh, wrong one. Go see the death plants. You give birth. It's very strange.
So there's a real sense of the kind of ecosystem in this part of the game.
Yeah,
now, isn't
it does.
We're working out we've now learned what different food types different plants and animals need, where to get them from other plants, and how to maximise the life that we're kind of creating, how to grow the ecosystem
and as
for
you can see,
our own gain.
We've already maxed out our biomass in this area. When I came here, there was nothing alive. I am the bringer of life. Lang.
I bring you hellfire.
But
Call me Jesus.
You bring life and death in the form of these...
and acid, apparently.
Oh, loads of acid.
Yeah, I keep picking it up.
In the sense that these plants are eating the little spider guys quite happily.
Yeah.
Which is a nice reversal on Earth, isn't it, where the animals eat the plants. At least here the plants are eating the animals.
Well, I think they're all weirdly
All
plants.
eating each other.
Yeah, it's the free-for-all.
It's the full system.
Oh, and look! The big green thing
Another
is
little
glowing.
There you go.
Ow!
Oh,
Damn you, damn you, robot! I can't move when the robot speaks to me, so I get hit by things.
Right in the spine.
I know. Wow, he's paralyzed. That's his weak point. And that's the end
And that is the end of the game.
Lang's
Yeah.
adventure. Well done, everybody. Well, guys, we have officially awoken Mars. It's awake. It's full of beasties. I'm so sorry. And that actually puts you out of a job, Lewis.
Yes.
Well, there we go, exactly.
there's
Stop looking.
lots of life
You don't need to
on
look for life anymore. We found it.
Arguably,
and
there's
we've
more
grown it
life
ourselves.
there. And arguably, it's more intelligent than some of the life on Earth,
But
right,
also
guys?
arguably, it's really, really quite dangerous. I'm quite happy.
Most of that life was out to get you. The carnivorous triffid plants,
Only one.
scrabbling spider animals.
I think I really learned the most science when feeding one life form to another, like ushering them in to their death.
I mean, that is life, though, right?
That's
Isn't
when
it?
I felt most at one with science.
Well, I suppose, on a planet like that where you're potentially the only sort of high intelligent life, you are really playing God there.
I don't know if Lang was that intelligent.
I don't know.
He was too busy being melancholic.
It was
He
just
was a bit of a downer, wasn't he?
a very accidental sort of giving of life and creating of ecosystems.
Did I find Mars, or did Mars find me? That's what he was
Wistful
like.
1,000-yard stare into the distance.
Is that something that astronauts need to have?
Yeah.
Yeah, yeah.
Is
Well, I
that part of
suppose
the
if they
search
didn't, if
criteria?
they don't leave with it, they'll certainly come back with it after all of that radiation you were telling me about
And then
from
the space
supernovas
madness,
and-
maybe. Yeah.
Yeah. Space
and,
madness.
And looking to the horizon to see
This isn't regular madness at all.
Space madness. Well, there we go. Thank you so much, Lewis, for joining us
Yes.
for all these
Thank
episodes
you, again.
of Space Explorers. I hope you now understand all there is to know about life on Mars. I know I do.
I do.
And
we played some fun games on the way.
Yeah.
Absolutely.
But there's I think more to learn about life on Mars,
Yes.
and it was proven by the fact that you have sent in a bunch of questions that
Yes.
you want to know all about life outside of Earth, and we're going to be fielding those questions to Lewis in our last video, which is part 2 of this episode, Waking Mars with Professor Lewis Dartnell.
Absolutely. So look out for that. But thanks for watching this video.
To them.